Good morning. This room's a little bit more full than it was. I hope everybody is handling their hangover well. I'm Stephen Baker. I'm going to talk about DSLs. Before we get started, I have a special feedback email address. If you have any complaints, Ali said he wanted to talk about feedback. So please send all of your email to there. And don't fucking tweet at me. Let's see. This is me. This is where you can find me. I'll probably ignore you. That one probably should have come first. Okay, so I'm going to talk about DSLs. I assume everybody knows what a DSL is. So we're going to talk about domain-specific languages. Martin Fowler kind of wrote the book on this stuff. I have a really great story about the DSL book that Martin Fowler wrote for later, when there are not cameras on. So a DSL is a computer language that is targeted to a particular kind of problem rather than a general purpose language that's aimed at any kind of software problem. Look at me, I can read off of a fucking TV. So there are Martin talks about two different kinds of DSLs. I'm not sure if I like this categorization, but he wrote the book on it, so I'm going to use it. An internal DSL is a way of using a host language to give the host language the feel of a particular language. This is technically what we do when we use Ruby to build DSLs, but practically, I think Ruby is way too good at building DSLs to be put into that box because it's as good as, or better than, external DSLs, which have their own custom syntax, and you have to write a whole full parser for yourself. And I don't know about you, I haven't enjoyed writing parsers since I was about 12 years old, and I'm not going to do it again. Fortunately, Ruby has several great parsers. And we can leverage those. So in everyday life, we see, I should probably look at my fucking notes, actually. Okay, so SQL is it's kind of contentious. Some people talk about it being a DSL. I'm not so sure if it's a DSL or not. It kind of is. It's kind of a general purpose language because it has a lot of, you can actually write a lot of stuff in SQL. And you can use Ruby for the databases too, so it doesn't matter. Another example of a DSL that I really like is GNU Lilypond, which is for typesetting music. It looks like this. It gives you the most beautiful typeset music, and it understands music notation and music theory better than many musicians. To a fault. It's really fucking hard to make guitar tablature in Lilypond, or it's almost impossible to sheet bluegrass music, or old blues from like the 30s and 40s, because every once in a while there's just an extra half a bar shoved in somewhere. And Lilypond does all the math. And if you email the mailing list and say, hey, it'd be really nice to be able to turn off the fucking math so I can typeset what I want, they say, no, that's not music. So the domain that the GNU Lilypond mailing list is in, that DSL, is called arsehole. Capybara is another DSL that we use all the time. It's really great. It's a DSL for interacting with a website. We use it in our tests. We use it for scrapers. We use it for all kinds of great things. Excellent example of the kind of DSL you can build with Ruby. Active Record, I put this one in here just to piss people off. Does anybody think Active Record is a DSL? Okay, you're wrong. Active Record, there's no magic in Active Record, it's just Ruby. Active Record, what looks like a DSL is actually just a bunch of class methods. So it's not really a DSL. I think Rails as a whole is a DSL for building web applications, but I don't think Active Record alone is. but the people seem to be divided on this one. Does anybody got any other examples? Oh, fuck. You guys are not gonna like what comes next. Which? What is that? The Cypress, the web testing thing. Yeah, it's actually kind of nice to use until you run out of memory. So, but those 8 seconds are really good. It's like node applications are like rodeo for your computer. If it can hang on for 8 seconds before it crashes, it wins. Why Ruby? There are a lot of great reasons why Ruby is perfect for DSL. Not perfect, nearly perfect, that we actually get paid for. Perfection has been achieved in 2 programming languages, Smalltalk and Lisp. And Ruby is the closest thing we have to perfect that we can get paid for. And so Ruby's really great for DSLs. It has beautiful syntax. There are few keywords. The blocks use plain words. You can use curly braces for your blocks. But even normals know what do and end mean. They can sort of figure that out. So that's kind of nice. And optional parentheses. They're not actually optional on my computer. They're only allowed to be used when the compiler requires them. That's called Seattle style, I heard. If you spend enough days in a coffee shop with Ryan Davis, you will stop typing parentheses. And then you will have seen the light. Eval gets a bad rap. I love it. Anything that lets me more easily run Ruby code wherever I want to is a great feature, and I love it. You can, eval means you can load any code anywhere, ship a binding with it, and it has access to whatever the hell is touching. It's super powerful, massively abused, but the great thing about it is it's powerful, so I get to enjoy it when I would like some power, and it's abused, so I can get paid to clean up the messes. Bindings are a really great feature of Ruby where you can take a binding, which just basically gives you a window into a scope. So you can say, I'm gonna put a bookmark right here in this piece of code, and then sometime later, I'm going to run some other code right there. Continuations do some similar things too, and you can do some really cool things with that. Bindings are awesome. Bindings are, I'm pretty sure, how ERB gets to be awesome. Post-conditionals. They make it easy to write things that look like sentences. Humans don't say, if it doesn't rain tomorrow, I'm gonna mow the lawn. They say, I'm gonna mow the lawn if it doesn't rain tomorrow. That's way, way better. I have a personal rule about if statements, so I only use them as post conditions and only as guard clauses. About every 18 months, somebody asks me a question or wants some help with something, and I have to go look up the Ruby docs to figure out how to write else if in Ruby. Because of the way it's parsed and the way that if and else work, I'm pretty sure you can do if, block, else, space, if, whatever, because they're all expressions. I'm pretty sure that works. But Ruby has another keyword, elif or elsif, I don't know, because I don't use it, because it reads like shit. Also, I forgot to mention unless. I love unless. Also great. Sensible block syntax. The block syntax is really important. One of the very, very few new features that I like in Ruby, because I write Ruby 1.8, I just run it on 3.4 and it goes so fast. But to me, perfect Ruby was 1.8. So I think maybe we should change the name of the language to like Ruby finally legal or something like that. Because Smalltalk was named after the year it was perfected in, right? Smalltalk is Smalltalk 80. They call it Smalltalk 80 because it was perfected in 1980. We should do the same thing in Ruby. It was perfect in 1.8. I don't remember when that came out. But it was perfect. The new hash syntax is really nice for DSLs. And that's a fucking lie. I was just trying to think of something nice to say about the new hash syntax. So Ruby's perfect for DSLs. It's really great. So the first thing, a lot of people complain that there's magic in Ruby, or in Rails in particular. But there's no magic. There's only Ruby. What looks like in Rails, what looks like magic when we run validations and things like that, those are just class methods. When we are building templates and doing rendering in Rails, that's just Ruby with a binding. There's nothing magical going on here. It's all lovely. The whole thing is awesome. And Ruby, there's no magic in Ruby, but Ruby itself is magical. It's great. The best thing about it is the people. Some of my best friends that I've made in my life are from the Ruby community. I got married to my wife 23 days after we met on the way to a Ruby conference. And we were living on Vancouver Island at the time, and I was going to Santa Clara to talk at Ajax World. And my wife had never been to California. Well, she was still my girlfriend then, but I barely remember. It didn't last that long. 23 days later, I told Ryan Davis and Eric Hodel and Joe O'Brien, I think Robbie Russell was there, like old school Rubyists. We were all going to the same conference. And I told them, hey, I'm getting married on my way to the conference. My wife is coming with me. And Eric Hodel said, sure, we'll see. So we're driving now, and we stop in Reno. I wasn't planning on telling this story, but it's funny. So we're driving, we're gonna go, when you drive down I-5 from Vancouver, from like Seattle to California, to go to Vegas is 7 hours out of the way in each direction. So it was gonna add 14 hours. And I don't usually, I work in web software, so I really don't care about performance optimization that much, but I knew that if we got married in Reno instead, I could be married 7 hours sooner, because Reno was on the way. And so we pull up to Santa Clara. I wasn't sure if it was the right hotel or not. And I parked the truck, and my wife said, I'm just gonna wait in the truck. You go check in, make sure this is the right place, and then come and get me and get the bags. I said, okay. So I walk in the front door of this hotel, massive lobby, 3 stories in the lobby, stairs and everything, and I walk in the door, and there's a semicircle of chairs, 13, 14, 15 chairs, and all Rubyists that you know. This is 18, 20 years ago now. It was 2006, what is that? 19 years ago. And I walked in, and Ryan Davis goes, hi, Stephen, so where's your wife? And everybody thought they had me. I said, she's in the truck. You get to meet her soon. And they did. So that's Ruby community folklore. I told that story in San Francisco when I went over with Sergey to Roman, who is active in the open source community. He's on the Apache Software Foundation board, and I think he's involved in the Linux Foundation as well. And I was telling that story, and we got to the end. He said, I've heard that story before. I said, where'd you hear it from? He said, Tim O'Reilly told me that story. And I said, well, It was his conference. Oh, whoops. Sorry, I buried the lead. I got to the conference, and they were going to reimburse my expenses for driving down. So I get in there, and when I'm traveling and expensing stuff, I have an envelope system. These are expensable, these are non-expensable, but possibly tax beneficial. These are my other receipts. And I grabbed all of my envelopes of receipts and walked into the admin desk at the conference, and I handed her an envelope, and I said, these are my gas receipts. She said, great, I'll get a check for you. And she opened it up, and I noticed it was the receipt for my wife's wedding dress that we bought 2 days earlier, and I said, shit, I'm sorry, I gave you the wrong envelope. And she goes, okay. And so I handed the right one. I said, sorry, that one's for my wedding. I should have handed that one to you. And she goes, why are you carrying the receipts for your wedding around? I said, because I just got married yesterday. And she goes, why did you come to a conference the day after you got married? I said, no, I got married on the way to the conference. And she said, that's a great story. And she pulls the envelope out of my hand and adds that number to the check too. And so the conference paid for my wedding. And it was Tim O'Reilly's conference, so Tim O'Reilly paid for my wedding. He had nothing to do with it, except, he hired the people who hired the people who hired the people who signed the check. Absolutely not involved at all. And then telling the story as though, to other people as though he had something to do with it, which is classic Tim O'Reilly. Maybe he'll publish a book about my wedding and get rich off of it, because that's how he made a name for himself, was writing books about things that other people created. So, anyways, really sorry about that tangent. Not really. I am not drunk enough for this. Okay. So this is an IRB session. It's true. Does anybody not believe that this is completely true? Has anybody ever written code like this before? Nice. I don't even know. I went through this code in parsetree with parsetree, the old version of it, because that's one I'm more familiar with. And I still couldn't figure out how the fuck it worked. I know how to get it to do that, but I don't know how it works internally. Oh, hang on. Oh, I did have the code on the slide there. It's one really long line. So the trick is, every one of those is a method. And everything returns nil. However it works out, I don't know. I'm not that smart. That's why I do TDD. The test passed, so it must work. So we're gonna make a DSL. Because I'm a one-trick pony. Oh, yeah, this motherfucker, Chris, this is his fault. He told me at the last conference we were at, he said, I think that it would be really interesting if you talked about how you might build something like RSpec and build DSLs in Ruby. And I said, that's a terrible idea. And he said, I would go, and I really like hanging out with him, so don't miss his talk. It's coming up next. I'm not even sure if he's here. He's probably working on his slides. Oh, there we go. I tried to get Grok to put some lipstick and mascara on him, but, and also a couple of weeks ago, Grok stopped putting dicks on things when you ask it. It just says no, which makes it useless. It's still as useless as every other AI thing now. If it's not, I mean, that's what AI is for, is making dumb jokes, right? So this is a DSL, which you've probably seen before. And this is close to the original version of RSpec, but I figured I can just show you how easy it is to do this kind of thing. Because I started building this iteration of it at about 4:30 this morning. While I was waiting for Sergey to call me to go for whiskey, and he never did, so I wrote another DSL. So we'll work from the outside in, which is not necessarily how I would build it, and because test unit already worked, and true to the original version, it wraps test unit, not mini test. Because I still have the memory of how to hook into the test runner in test unit. One of the other people on the core team for RSpec insisted, and I don't remember which person it was, insisted that we don't ship the first version of Ruby Gems until we had our own runner. And I thought that was a terrible idea. I want to be in the business of making it nicer, possibly, to write tests. And it was misguided. I was young and stupid. Now I'm old and stupid. And so my youthful ignorance, I decided to do this thing, but I thought it would be really nice if it's still test unit compatible. So it just hooks into test unit and calls test unit. So what we're doing here is we're gonna create a new class, but you can't use the class keyword inside of a method. And so you have to just new up a class, and you pass in the superclass as an argument. And then we're just gonna class eval the block, and then we're gonna return it. That's it. Then we're gonna add it to the context. So, I missed a slide here. Hang on one second. There, this one on the bottom. So in the original version, describe was test : unit, and context was test unit test case. So that it would be called describe context. Now it's called example and example group because Brian Merrick is smarter and better at naming things than I am. And so basically we just hop into context, which is a subclass of test unit test case, and we define it, which takes a name and a block. And all it does is define a method with the string, spaces and all, and passes the block through. That's it. And so then we wrap the assertions. Now this was the original, closer to the original syntax. It was assert that block, and then the block would return the set of matchers. And it didn't fit on the slide, but I had a script, and then I threw it away because it wouldn't fit on a slide, that just iterates through test unit test case, any method that starts with assert, and then just creates one like it. And so basically, in this case, you would say assert that block dot does equal and the actual. The one thing that I miss when I'm not using RSpec is I always get expected and actual flipped around, which fucks up your error messages. And I started counting how many times I did that while I was TDDing this, and it's not like I don't use mini-test and you know, I don't do TDD every single day. 20 times I flipped expected and actual because they are not consistently named. Assert includes is the one that drives me nuts, because includes, you pass the collection first, which is the actual, and the thing you're looking for is the expected, but assert equal is expected actual, which is better. Let's see. Oh, whoops. There we go. Fuck, I'm missing a slide. Okay, whatever. Let's do something cool. So that's one DSL. The newest version of ours, or the oldest version of RSpec that's available on Ruby Gems, because that was Chris's original suggestion, was take the original version and walk through it. The oldest version of RSpec that's in Ruby Gems is like 4 years old. Is 4 years old, 4 years younger than RSpec actually is. And I have no idea where the original code is. It's in a monotone repo somewhere. Does anybody remember monotone? Back when we had version control that you know, didn't suck ass. We didn't need billionaires to start we didn't need to create a bunch of billionaires to go and create a website to make monotone awesome. It was already awesome. So let's do something useful. These are pictures from my buddy's barn. Mapti lives in the next village. He's a great dude. His day job is he works on industrial CNC machines and robots in factories and stuff. And every once in a while, he gets a good deal on an old one. So this is, hang on one second. This is an ASEA IRB L6/2, or as I have recently taken to calling it the L6+2. That's a robot. It's pretty light duty, and as I understand it, it's pretty light duty in the way that these things go. Built in 1986, 84 to 86, I think. It's got an Intel 8008 processor, which is the one that was in the Altair, I think. It's got, you program it by pushing the buttons on the control panel there. This cabinet next to it is the actual computer, and the wires down here that go into the cabinet are analog. So my first thought, because Matthew showed me this and said, hey, we gotta get this going. And I'd like to connect it to a computer. And I said, no problem, cut off those cables and we'll hook them up to the GPIO pins on the Raspberry Pi. And he said, nope. Those are analog and they're finicky. And plus, the cabinet's complete. Why don't we work with that? So we're gonna see in a minute, you can save software in a programming language that sort of looks like BASIC. And you stick it on a 5¼ inch floppy, which I think is the low density one, whatever the rarer one is. Or you can program it by punching numbers into the keypad and waiting. The first thought that I had was, how do we get things out of like Linux CNC or some other software into this thing to get the robot to move around? It's fairly light duty. It's for like painting, and the slightly larger version will do welding. But it's like, as I understand it, as far as these things go, it's got like a low weight limit and stuff, so it's more for, you know, moving around, having fun. It looks pretty cool. I should have put the video up there of it running. Anyways, one of the ways to interface with it that we thought about was, hey, what if we had like a small computer, Raspberry Pi, Arduino, or I've been playing with the ESP32 stuff lately. What if we just emulate the floppy drive, but ship it data from a computer, and it can just be a floppy drive with unlimited storage, and that'd be pretty cool. Turns out emulating that particular floppy drive is really difficult, and you have to get the timing right for whatever optimizations they would have done for head slippage and all that stuff that happens with mechanical floppy disk drives that are almost 50 years old. There's another picture of it. This is the picture of the control panel from the manual. Because this was made in the previous century, it actually has documentation. The documentation is correct. And somebody built a time machine and went back to 1986 and made PDFs. So it's pretty cool. I've got a PDF. I asked Matti for the manual so I could get some of the code examples. And I thought he was going to send me pictures of the Swedish manual. And but he actually had the English version of the manual, which is, you know, better because I might actually be able to get work done. But the Swedish dialect of BASIC is really funny. So we're gonna use Ruby to generate programs that will eventually run on the robot. So this is an example of a very simple program that runs on the robot. I made up the comment character. We couldn't afford comments in the 80s. And it's got line numbers. And you know, the comments tell it what it does. It basically just, you know, sets a min and max when you initialize speeds. You tell it what method you're drawing in, where's the starting point, and where's the position when you're at 100%. When you're moving, how are you moving? What are the increments you're moving in and stuff like that? It has to be very precise because it might be the kind of thing that, you know, painted a car, or it's also used as like a picker machine, so to like sort bolts. That's actually one of the things we want to do with it. We want to get like a Raspberry Pi with a Raspberry Pi camera and dump bolts on the table and then use image recognition to figure out what size the bolts are and have it put them in the boxes. Because it'll take me way, way, way longer to write the software to do that than it would to actually sort the bolts. So that's what the program looks like. And I don't really want to. There are a whole bunch of benefits to being able to write Ruby instead, but that needs to be the output. Whoops, sorry. So how do we know that this is a perfect candidate for a DSL? What about this? And this is basically just the text version of what came out of the manual. What about this makes it a perfect candidate for a DSL? How do we know? Okay, fine, I'll tell you. It's because of all the comments, right? We have comments because the language just isn't that expressive. And it's not their fault. They're dealing in, engineering is I think this is Glenn Vanderberg's definition, and it's my favorite definition of engineering. Engineering is the intersection of art and constraints. And in the software industry, we've been basically unconstrained for probably 15 years in most cases, and it shows. So we can make it a little bit better. So let's try, this is iteration 1, let's try that. So, oh yeah, some transition that didn't work, okay. So one of my favorite things that I don't remember where I learned this, I might have made it up myself. I might have got it from Corey Haynes, he might have got it from somebody else, I don't fucking know. Design by wishful thinking is one of the practices that I do all the time. You design for the interface you wish you had. And this is really great in DSLs. I think Jim Wyrick called it README-driven development. Write the README for your program, and then implement the README. The Elixir folks actually do a really neat thing. The README is usually in whatever Elixir's equivalent of ERB is, and they just rebuild the README. And that's really cool, because you can do things like read from the file system which version of Ruby you're using and stuff like that. And so if you write the README first, or if you write the acceptance test first, or if you write, here is how I would like to interact with the world, that will inform what direction you go in. This is also how I use mock objects. When I'm building something, I'm building a class over here, and I really need a class that does this thing, but I don't want to do that right now. So I'm just going to mock it. And then once I use it a couple of times in my tests, I already have the mocks telling me which methods it needs, what arguments they take, what the shape of it is, and it's being driven from the end user perspective of the API. And it leads to a cleaner API. You're not building stuff that you don't need because you're building just what you need to be able to move forward. And so this is how I approach this problem. Okay. All 3 screens are out of sync by about 100 milliseconds, and it looks like it's jumping 2 or 3 slides ahead from my perspective, which is why I swear I'm not drunk yet. Okay, so this is what I thought if I was going to program the thing from Ruby and also be able to, Matti is super smart and he would make an excellent programmer if he would, learn, but he's sensible and he would rather actually play with robots. And he also builds guitars and stuff too. He's a great dude. I want something that a normal could learn pretty quickly, and I thought this was a, pretty good first crack. So this is what I want to write in Ruby to get the exact same output that is in the documentation, which is this, in case you didn't memorize it. And so why do I want to write code in Ruby that shits out code in some other language that's been dead for 40 years, and then ship it? Well, we get all of the excellent tooling and the ecosystem that comes from Ruby. So we get, we get Rake. Rake is awesome. We get Ruby, which is the best language that we're allowed to use at work. And, it's just lovely. So this is the actual DSL. So the first one was, the slide that looks similar to it was what I was hoping to go for. This is what I ended up having to go with. And so print program at the end, I don't really like that. I think I should probably, in start program, probably print at the end of the yield, but first crack at it. And when I run my sample program, this is the output. The only difference between this output and what was in the documentation is the line numbers are different. The line numbers don't matter. The line numbers are because we didn't have editors that could move the cursor around, and so if you need to put a line in between, if you needed to put some code in on line 1.5, you would just call it 15. Fractional lines is a feature that Ruby doesn't have. And I don't really miss it. So this is what the robot DSL looks like. So we've got a robot program. We instantiate that, we add a line. This is the low-level bit, right? And at the end, we add return. Return tells the robot to go back to wherever to go home. The benefits of this, tooling, refactoring, we can use Ruby to fetch data from the net. I can use Ruby to convert from another file format. One of the things I really want to be able to do is take an STL file or a 3MF file that has a 3D model in it and have the robot have a program that imports the STL and then tells the robot, I want you to cover this 3D object in its entirety and only be this distance away the whole time. And it should have the accuracy to do that kind of thing. By using a full-fat programming language, we can do these kinds of things. I want to be able to write tests for my robot programs because I'm not very good at my job. I'm not very good at this computer thing. It requires a lot of braining. And so I want to write tests. I would like to create graphical tools that will simulate the robot's movements so that I can do a thing and then watch it before I actually load it into the robot because the robot's pretty slow. I'd like to support different kinds of robots with the same language because we might, between the two of us, we may come into possession to some more robots. This slide intentionally left blank. Yes, okay, good. What the fuck? Where'd the rest of my slide go? Shit. Well, okay, well, the rest of it looks just like that. Hang on. Where did it go? Hang on 1 second, we're gonna do it live. I'll just show you quickly and then I'll go find some whiskey. Let's do this here. So, all right. So this is the DSL here. All right, there we go. And then if I pull up, let's see here. So it's all fully tested. So each command has a test and sometimes more than one assertion to get the output. That's not that interesting there. Here is the robot. Here's the implementation of the robot DSL. There's a whole bunch of nasty shit in here. I don't know how to deal with this. These are constants that need to come out as strings on the other side. I'm not quite sure what that looks like yet. Don't know. Oops. It's fine. That's not a comment. That is actually an output for the program to tell. I think it uses smaller movement increments or something like that. And so basically, there is literally just a method. This module is every command that I have in the DSL. And it maps to another one. I'm going to build a class per command so that they compose nicely and so I can handle arguments better. And then, let me see here. And this is the robot program. This is the thing that actually stores the things. This is the low-level bits of it. This is nasty. I was very tired. And that's the original. And this is the actual end product that generates that code. And I think that's it. I don't know where those slides went. Anyways, now you've seen it all. You should do some crazy shit with DSLs. And I don't think we care what time it is anymore, but I have nothing else to say about that. Unless anybody, I don't know if we're doing questions or not, but you can find me and ask, and we can talk about this stuff. Cool. Thanks.